SAT prep. Let's go. It's late. I don't care because we got work to do. Okay, so we're going to do the last 7 assignments in Passport to Advanced Math. Okay, so 1, 2, 3, 4, 5, 6, 7. So operations with polynomials. Let's go. How hard could it be? Which of the following is an equivalent expression? You know what? This is the only problem with these videos is that I'm doing the most basic ones. But hey, it's okay for me, and then gives you more to post in the organizer. So make sure you distribute the negative, and you should be good to go. Okay. Foil it out, foil it out. That's what it's all about. Let's do a shortcut though. We can since our coefficients are 1, we already know we got the x squared, and then we know they add to give us the b, so -6 plus -1, that's -7x, and then of course they multiply to give us the middle number. So there you go. I mean, I said the middle, the n number. Oh, and then, okay, so then this one, we just double it. So it's -20 in the middle. And then -10 times -10 is 100. Well, if you do this one, it's just as simple as that. Okay. And positive 32, and then -12 in the middle. Okay. All right. So operate. They do a good job there. Now let's do polynomials, factors, and graphs. Okay, so we have this polynomial in factored form, and so you know that the zeros are the opposite of the factors, right? So we know that we have +7, -5, and even this one's not too bad. We know that it's going to be +3. Just make sure that you put it over the 2 because of that 2 coefficient. So +3/2, -5 and 7. A polynomial function f is defined as that which of the following is a 0 of the function. Okay, so so which is an integer, so it's got to be this one. So it's got to be -2. Because we see +2. Oh, square root. No problem. It's still going to be that the zeros are √3 and √7. That's it. That squared on the outside just means that the multiplicity of that 0 is 2, which just affects the way that it intersects the 0. But it's still the 0. And you can put that in the organizer if you have a question. I bet someone is going to accidentally pick C, but not you. A polynomial function m is defined as m of x equals 2x minus 3, x squared plus 3x plus 10, if m of a equals 0 for some real number a. What is the value of a? Well, we know the value. Well, a could be 3/2. It could be, there's 3 different answers. So I'm just going to put in 1 and see what happens. Although I think it's going to be 3 different answers. Yeah. Okay. Wow. They chose the same one that I did. Oh, actually this one has the discriminant is negative. Do you remember the discriminant? Let's talk about that just really quick. The b squared minus 4ac in the quadratic formula, if that is positive, then that implies 2 solutions. But if b squared minus 4ac is 0, that implies there's 1 solution. And if it's negative, that implies there is 0 solutions. Don't forget about the discriminant. The polynomial function h is defined above. How many distinct zeros does it have? So I'm looking at the factors. 1, 2, 3, 4. 4. And so I'm going to put 4. Don't be fooled by those exponents. The factors are the zeros. Trying to trick me. Okay. So now let's go to nonlinear equation graphs. Where's the graph? It said graph. The equation y equals 2x squared minus 7x plus 1 is graphed. What is the y-intercept? The y-intercept would be, since it's in standard form, right there. Okay, but if it was in vertex form, it would not be 1. We would have to substitute 0 in for y and solve for x. Maybe they'll give me one like that. Which of the following is the x-intercept? So I have a little song that I sing. At the x-intercept, the y is 0. At the y-intercept, the x is 0. At the x-intercept, the y is 0. So we get the x-intercepts. So we know it's like this. And we know we got 2 of them. What are they? Yeah. Oh. Well. I don't know why I did all that, because this is very easy. The x-intercepts are the zeros, so it's just 3 and negative 9. I was thinking that maybe we were talking about the y-intercept, but I had not read it very closely. Vertex form. Did you know that was in vertex form? I gotta know that. What is, and so what are the coordinates of the vertex? Very simply, they are 3, negative 4. The number on the inside changes sign to get to the vertex, and the number on the outside is simply what it is. 3, negative 4. So now we've done all 3 quadratic forms. Standard form, ax squared plus bx plus c. Factored form, x minus m, x minus n. And vertex form, a times x minus h squared plus k. If the equation y equals 2 times 1.5 to the x is graphed in the xy plane, what are the coordinates of the y-intercept? So now here we have a exponential function. And so now this time the y-intercept is in front, and the b is the growth decay factor. Like the slope, only we know exponential goes in an exponential curve. It can be growth or it can be decay. And so the y-intercept is 2, 0, 2. The function f of x equals 2x minus 1 times 3x plus 7 is graphed. What are the coordinates of the x-intercept of the graph? You can do this. I'm not doing this for you. All right, exit this practice. We are rolling right along. Linear and quadratic systems. Okay. The quadratic equation is graphed to the left. Which of the following equations could be paired with the graph equation to create a system where the solutions are 2, negative 4, and negative 4, 2? Okay. So we want to know 2, negative 4, and negative 4, 2. So we see that those are on this graph, and we want to find the equation that most likely is like that. Suppose it could be like that somehow. But we're talking about a line. So we want a straight line. Let me use my line tool. So hey, this makes it a little bit easier. The y-intercept is negative 2. And so it can't be one of those two. And then, so let's put these guys in slope-intercept form. So this would be y equals negative x minus 2. And that does work. So that's the answer. All right. Quadratic equation is graphed. Which of the following linear equations combines to give? Okay, so 3 and 5. I'm going to use my strategy again. 3 and 5 halves. It's right here. And -2, -5. -2, -5 down here. And I'm just going to use my line tool. Why am I using this method? Because I think it's efficient. So the y-intercept is 2. And the slope, let's see if I even need to find the slope. See if I can get it with that y-intercept being -2. Okay, so the y-intercept for this one. Now, the thing about these equations is they're in standard form. So standard form of a linear equation looks like this. But guess what? The y-intercept is always C over B. C over B. That's what it is. So I want to find the one that has the y-intercept of -2. So C over B is -2. So there we go. Am I done? I am not. Neither of the points are solutions to the equation. What did I do wrong? Okay. -4/2 is -2. And that is the y-intercept. But it says neither of the points are solutions to that equation. So I should have been more careful to substitute in the points and make sure that they are solutions to the equation. I should have at least checked one. Substitute that in. We substitute -2, -5, so 3 times -2 plus 2 times -5, and that would be -6 minus 10. That's not -4. What was I even thinking? All right, so now I got to write that down. I got to put this in the organizer that I should have substituted in. You see? So it's okay. Got one wrong. Consider the following system of equations. I'm considering it. Where k is a constant. If the solution to the system of equations are the points 0, 3, and 5, 0, what is the value of k? Okay, so the solution to the system is where those two functions intersect. So that means -3/5 x plus 3 is equal to x minus 5 times x plus k. And so that's one way to think of it. So we want to, so we can see that, yeah, let me just pause this real quick so I can think about it. I'm all shaken up by that incorrect answer. Okay, I was thinking about it for just a second and I thought, this is what I want to do. I want to I know I have 5, 0, and I know I have 0, 3. And so the graph is positive over here, right? And it's positive over here. And then it's symmetrical. So there's a terrible graph, but it's like around 2, in between 1 and 2, something like that. So it's definitely not 3. I don't think. I think out of the choices, 3/5. That be it. Could be 3/5. I think that in order for the graph to be symmetrical, it's more likely to be 3/5 than 3. -3/5. Now see that that's just cold. All right. -3/5 is the value of, oh, do you know what? I was right, but I was wrong. Okay, so it's true that we wanted to choose the 3/5, so something like this. But in order for it to be the factor, it's going to have to be the opposite. Remember, Mr. Field, remember that? So we would have to have -3/5. See, it's like that. It would have to be x minus 3/5 so that on the graph, it's actually a positive 3/5. Even with the stopping. Okay, I gotta get this one. I gotta get it. Okay. Linear. Oh, if I was on a paper test right now, I would flip it over and start from the back. That's what I would do. But computer. A linear equation is graphed to the left. Which of the following equations combines with the graphed equation to create a system of equations whose solution set is comprised of the points -1, -5, and 3, 3. This time we have linear and we want the quadratic. So since I don't want to get it wrong again, I better substitute. I'm just trying to think of the quick way to do it, but I keep striking out when I do that. So, okay, so these are pretty simple to sketch on the graph. This one has a y-intercept of -6. And so, and then it goes up. Something like that. So -1, -1, -5 is possible. Oh, yeah, that's true. And 3, 3. No, that would make it not. That would not make it symmetrical. I don't think that would work. This one would go upside down. And I think that we want to pick the graph that goes right side up. But how about x squared minus 4? Well, that's not going to work either. Okay, so after some consideration, I am thinking that it is this one, even though my sketch was not symmetrical. My sketch was also pretty terrible. So let me, since I don't want to get it wrong again, substitute my point in. So use what I learned. So I know that would be 1 minus 6 is -5. So I already knew that one works. How about 3, 3? Does that work in this equation? 3 equals 3 squared minus 6. Well, see, now that is true. 9 minus 6 is 3. So it is A. No, I got it right. You see? All right. Last one here. A quadratic equation is graphed to the left. Which of the following equations could be paired with the graphed equation to create a system of solutions? Or a system of solutions. Yeah. Okay. So go ahead and try this one. You could do it. You'll get it. You'll probably get it better than me. I am exiting this practice. Okay. Structure in expressions. Now, this one is generally one that a lot of people struggle with. So let's talk about it. Which of the following is equivalent to the expression above? All we got to do is factor it. So how does that factor? What numbers multiply to 24 and add to 11? Why, that would be none other than 8 and 3, of course. Although there are other numbers that Which of the following is equivalent? So you can factor that. Go ahead. Factor. Is this just factoring? This is just factoring. Okay, you can factor. I don't know why people struggle with that one historically, because it's just factoring. You must know how to factor. Isolating quantities. Let's do, ooh, what a good assignment. We want to take and isolate one of the variables, solve for a variable. So important. So the equation, which of the following equations correctly expresses G in terms of? So that means G, okay, as we can see, G is on that side. So how are we going to get G on its own side? First of all, I noticed that G is in both terms, so I'm going to factor it out, and then that would be 12h plus 15, and that's right, that equals f over here, and then you can just divide both sides by 12h plus 15. And then boom, it's gone. So it's f over 12h plus 15. J equals m over c times 78. And then we want c, we want to solve for c. All right. So let me give you a way to think about it. Let's look at, let's say it's like this, 78m. You can just put that 78 in the numerator over c. And then we can put the j over 1, because then we'll have a fraction equal to a fraction. And I love that, because then I can cross multiply. Then we have jc equals 78m. And then in order to solve for c, we just want to divide by j. So c equals 78m over j. 78m over j. L equals 125m plus 50n. Okay, so you can solve for these. You can do it. Trig. All right, let's do this one real quick. So we want to solve for d, right? Oh, well, it's trig, but we're just dividing both sides by 2 and the sine of theta. So d equals lambda over 2 sine theta. That one, it wasn't so bad. Last one, guys, we're on the last one. It's been a journey to function notation. Okay, so you're going to substitute into f and then substitute the result into g. So what's f of 3? 3 minus 1 is 8. And so now we find g of 8, which is 8 squared plus 1 is 65. Was h of 1. What is h of 1? 2. Okay. So we got to find h of x is defined to be 2 minus g of x. So I guess we got to find out what g of x is. And so that's going to be, it's going to be 3 minus 7 is negative 4. 2 minus negative 4, which is 6. All right. A function f satisfies f of 1 equals 3 and f of 3 equals 7. A function g satisfies g of 3 equals 9 and g of 7 equals 1. What is the value of f of g of 7? Oh boy. All right. Let's now, of course, we could make equations, but we could also make tables. So let's make the f table and the g table. And then we'll see if that See if that is enough. So F has 1, 3, also has 3, 7, and then G has 3, 9, 7, 1. So I'm always trying to think about the most efficient way. So G of 7. Do we already know that one? Yeah, that's 1. So then we want to find F of 1, and we already know that. G of 7, that's our first step. Second step. The answer is, what is F of 1? It's 3. So we just had to make a table. All right, so now they give us the equations in this one. So you'd substitute and then substitute your answer. We did that. We did one like that. And last but not least, substitute and then substitute your answer back in. You could do that. I don't want to spoil your fun. All right, so that is the end of Passport to Advanced Math. We did it all. So now the last thing we're going to do is some problem solving and data analysis in week 6. But I'll save that for the week 6 video.